In this tutorial, we are going to talk about ASP.NET Core Middlewares. It doesn't matter which SAP technology you are using. You may use MVC, Web API, Rather Pages. It doesn't matter. At the end, you need to have a clear understanding about ASP.NET Core Middlewares. We'll explore what is the role of middleware, why you need to create your own middlewares, how to create your own middlewares, and we'll try to answer all the possible questions around this topic. Hey, my name is Tural, and this is my channel where I'm sharing my knowledge about .NET, C#, JavaScript, Node.js, microservices, Docker, etc., which I'm using in my daily practice. If you like my videos, please don't forget to subscribe, hit like button, share, and let's get started. Of course, before diving into practice, we need to understand middlewares in theory. For that reason, I will start everything from scratch to help people to understand, to gain really valuable knowledge, even for beginners, okay? Here we have a client-server architecture, and in this architecture, this is a really simple architecture, so you may have different type of clients, and we have request response process here. So client sends some sort of request to our server. Our server is responsible to serve the data, okay? And here in our server, we have application. So when you build your application, your MVC, Web API, it doesn't matter. You are putting this application to some sort of server, to some sort of infrastructure to live there. And our server is responsible to interact with client and return response from our application to the client. And in our client-server architecture, we have really simple request-response process. But that's not enough to understand the role of the middleware in our application. So we need to have a big snapshot, a detailed snapshot about the client-server mechanism here. Here in our scenario, we have a little bit zoomed version of our flow. We have, again, client. Client sends a request to our server. This server may be a physical or not. At the end, we have some sort of infrastructure to handle our request. Okay, and in our server, we have server application. If you want, for example, to make your computer also a server, you just need to install a server application and to do proper configuration. In our case, we have a server. Let's say it is a physical device, physical PC, and we have a server application. This server application may be Apache server, Nginx, it doesn't matter. Whatever server you want to use, you can use. And this server's responsibility is to listen our clients, to get request from our client and forward it to our application. In our case, application is going to be our ASP.NET Core application. In our application, we already know that we have a controller. You may add the services, data access layer, it doesn't matter. This is just an internal implementation of your application, okay? But before reaching to your controller, your request will flow from a pipeline. We have some sort of pipeline, a backbone of our application, and we call it middlewares. So middleware built our application backbone. It is possible for you to have 20 middlewares or 4 middlewares. Actually, the size of middleware, the count of middleware depends from your application requirement. You can put HTTP redirection, authorization, authentication stuff, static file checking, or additional business logic, logging, etc. to your middleware. We'll look some simple middleware creation in this tutorial also. So before reaching to your controller, moving your classical services, data access, we have some sort of pre-initialization step, and it is our pipeline. The pipeline built using middlewares. As we mentioned, we may have the 40, 15, I don't know, 7 middlewares depending from your application actual requirement. And the case here is that middleware acts not just in your request process, but it is also acts in your response process. So your request, as you can see, flows from your client to server, server to server application, server application, the Apache, Kestrel, Nginx, doesn't matter. They redirect query to your original application that you host, that you build using C#, using ASP.NET Core, and the request comes to your middleware first before coming to your controller. And here, the order of middleware actually matters. We will talk about it also. So this is our first middleware, second middleware, third middleware, and at the end, request reaches to your controller. Actually, the last middleware here is responsible to redirecting the query to your controller. Okay, we have built-in functionality to redirect query to your controller. We'll look at this functionality also. And here we are receiving this request from user in our controller, and we are doing internal stuff. So in general, when someone starts learning ASP.NET Core, they think that the application's internal stage is controller, because in general we are talking about the controller. The request flows in a layered manner to the service, to the data access, depending from your architecture, of course, but actually in a physical manner, before everything else, before your controller stuff, we have middleware. Actually, in our application, as you know, the ASP.NET Core application is a console application. It builds the server, and this server injects our services, and then request flows to our middlewares. And when we're done with request, the final stage here is our destination. For example, in a classical data-driven applications, we have some sort of storage, data storage, Transact SQL, PostgreSQL, it doesn't matter. You are sending some request to get some data from the database. This is a classical example, okay? Of course, you are able to not to reach to the database, but just return response based on user request in your service layer, directly in your controller also. But let's say in a classical manner, we have a database here, and the user wants to get some data from our database. So database acts here as a final destination. And when we reach to the database, request flows from the data to the business logic, and from business to the controller in a classical layered architecture, and then request flows back from middleware 3 to middleware 2, and from middleware 2 from middleware 1. So you have A to Z and Z to A flow. So the request flows from middleware 1 to middleware 3, and the response also flows from your pipeline from middleware 3 to middleware 1. This is really important to understand, because middleware is not just responsible for handling your requests, but also responsible to work on to do some additional logic over your response also. Okay, so at the end, middleware acts as a backbone, acts as a pre-initialization and post-initialization of your queries. So we have request and response flow, and middleware participates in all these both operations, in your request and in your response also. Now let's open our Visual Studio and try to learn everything in practice. So we have the CodeByte solution here. I'm going to create a new branch. This is going to be our tutorial. Middlewares. I will share the link with you below the video, and let's right click, add new project, and from this project let's use ASP.NET Core Web API, and I will use this template. Let's call it learning middlewares, and .NET 8, that's completely okay, blah blah, everything is okay. Let's create, and here we are. Let's go to the program CS first, because everything for us starts from the program CS, okay? In our program CS, we have the main method. So simply this ASP.NET Core Web API is going to be our simple console application, okay? This console application instantiates our server, and we are able to inject some services which we are going to use in our controllers. Okay, so using builder services dot add some service, we are able to inject our services. We'll have a separate topic about the services. Let's focus to our middleware. When we build our application, this instance here will help us to inject, to add our middleware pipeline, to build our middleware pipeline. So you see, we already have some sort of built-in middleware mechanism here. So this is really simple. It checks if we are running our application in a development environment. It will add some sort of Swagger mechanism to see everything in a clear, in a beautiful manner. So we have HTTP redirection, use authorization, and map controllers that will help us to redirect to our controller. We have already talked about the map controller and add controller. Just check our dependency injection tutorial to learn more about it. What I'm going to do, I will just use this is development. The using HTTPS redirection is also okay. We'll have a separate topic where I'm talking about the built-in middlewares, but this topic is completely focusing on diving into middlewares, trying to understand, trying to create our custom middlewares. So this is a bit complex topic rather than using built-in middlewares, okay? We don't have any specific authorization mechanism here, so it is okay to leave it as is here. The important thing here is we have map controllers, and when we run our application, we'll see all this stuff using Swagger, and we'll be able to redirect our query to the controller stuff. Let me just run our application and see what we are getting at the end. Great, now we have our application. This is simple weather forecast. Let's just leave it as is. We are trying, executing, and everything is working. Why everything is working? This is really simple. When we instantiate our application in our program CS, we have a backbone of our application. The request comes from API environment is development to API run. So the last middleware element here is our map controller. Using the last run method, we are able to run our application, okay? What I am going to do, I am going to add, after Swagger, I am going to create my own middleware to see how I'm able to interact with pipeline, okay? So let's go to the app use. So we have special method called use. This is really important to understand this method. This method is able to work with delegates. We have two interesting tutorials about delegates where I'm trying to explain everything from scratch for beginners and for also senior developers. You can check if you don't have enough understanding about delegates. So you see we have func request delegate middleware here. I'm going to provide my context and the next item here. We'll talk about it. So in a simple manner, when we run our application, we are receiving some data from our client, and this data comes as a huge object in our HTTP context. So this delegate is able to receive this HTTP context because the purpose of the callback, the purpose of the delegate is called by some other functionality. So in our case, our backbone, our middleware calls our functionality with providing HTTP context and the next middleware also. The next here indicates to our use HTTPS redirection because the next indicates to the next middleware. If you have, for example, this use authorization as a next after our middleware, then the next indicates to your use authorization. Okay. Cool. So we have the context, and in this context, we have access to the request object. This request object was built when you send requests to your server. Okay, and in my case, I have access to different information, to the body, to the root values, headers, etc. So you can interact, you can do some sort of checking, you can do some additional stuff to see and to manipulate or to write additional business logic based on your request information. For example, you don't want to provide all requests to your server, to your application, and you have some sort of a secret header information. If user provides this information, then system will be able to interact, to send response to the client. In this case, you're able to interact with headers and check if in our header we have appropriate information, and after that you will allow for your users to interact with your application. The next here is going to be our request delegate. The use method is not the only method that helps us to build our middleware. We have some sort of other functionalities also. We'll talk about it, but for now let's focus on use. And what I want to do, I want to have a special header information here. So for my headers, I want to see if user is able to provide, if user provides, for example, secret header here. Okay, and we have some sort of out. Let's just out our data. Okay, and I am going to do this sort of operation. So try get value will return Boolean information, and this out will help me to get this value. Okay, so I'm going to check if this value is equal to, let's say, secret, then we will call our next. Okay, and this is of course the awaitable operation, async await. Otherwise, we are terminating the operation. If you are not calling the next, it means you are not calling the next middleware, and your request will stuck there and your application will not return the data to your client. In my case, I am just checking if user is able to send the secret header with secret value, then we will call our next middleware. Let me just run our application again and try to check everything from scratch. So I'm going to refresh and let's execute this query. So you see, in our case, we are not getting response because we are just not returning a bad request. It is going to be 200, but with no proper data. Let me just open our Postman. I will try to send data from Postman with a proper header information. So let me just copy the URL here. Okay, and what else we have? Weather forecast. Okay, weather forecast. Great. Let's just send, see. So you see we have 200. Okay. So this is a broken information. Okay. We don't have the real success 200 information, but we have headers here. And I am going to add one more header here. So this is our secret header. This is our secret header and with value secret. Great, let's send, and here we are. That's how we are interacting with our application. That's how we are creating a wrapper logic, a middleware logic for our application. Let's go back and let's repeat again. So we have HTTP context in our flow. When we run our application flows from top, from line 19 to 43. Okay, and here the definition of your middlewares is exactly the order of your middleware. It means if you define calling this uSwagger UI at the top, your middleware will start with these functionalities. This is your first middleware. This is going to be our second middleware, third middleware, fourth middleware, like this, okay? And here, when it is okay, so the uSwagger UI is a built-in integrated stuff here, so everything is okay, and our application flows to the use. Let me just show you, and I'm going to add one more breakpoint to our controller. Now we have use. We have a breakpoint in our use and we have a breakpoint in our weather forecast. Let's just run and see the real order. The first request should flow from middleware to our controller only if the provided logic matches. Okay. And let me just disable this one and send. And here we are. So you see, this was our first middleware stuff, the first checking, everything is okay here. We are able to run uSwagger UI. I'm just calling these two together as a one middleware, but they are a separate middlewares. So we have use, let's see our HTTP context. So in our HTTP context, we have all the request information, and from the request information, you are able to see the header. So in our header, we don't have any additional information related to secret. We have the postman token, etc. And this request unfortunately doesn't follow the business logic we want, and for that reason when I click continue, the breakpoint will not switch to the controller. So you see, simply application. And now let's add the secret header and send request. So we are here. It means that everything is okay. The value is secret. Great. Now we should be able to switch to the next middleware. Right now, this breakpoint will not work because there is nothing to breakpoint, nothing to internally see, and we are here. So you see, that's how we are working with our simple middleware. That's how we are building our simple middlewares. To see if request flows in case of success operation, let me just copy our middleware here and create just a simple middleware that calls, of course, the next middleware. And I am adding the breakpoint here. When I run my application, first the breakpoint should be here, and then when I click continue, the breakpoint should come here, and after that it should flow to the controller. Let's run our application again. I will use the postman because we have a special condition here. Okay, let me just send our request. So you see, we are here in our first created middleware. Let's continue. So everything is okay. When I call this next, this should call our real next middleware. Let's continue. So you see, we are here. And when I click continue, this should go to our controller's action. That's how the middleware flow is working. Okay. But the case here is our example is really simple and it shows only the request flow. But as we mentioned before, our middleware is not just responsible for request, but also but also participating in our response process. To make your middleware code to participate in your response flow, you should add your logic after await next. Okay, if you really want to see some logic, if you really want to interact with your response, you should add it before await next. So after await next, sorry, before await next, we are able to manipulate, we are able to check, to do some business logic over our request, but after await next, we are able to work, to manipulate, to write some business logic over our response. Before working our response, I need to mention that it is not recommended to interact with your response if this response has already been sent. So having some sort of logic like context dot response, for example, if you want to interact with your headers, for example, my header, okay, and my value, that's not a good practice to do. What is the best practice here? The best practice here is you need first to check if response has already been sent. It means if our context response has started. If it is not started to send, then you are able to do some additional operation over your response. But if you are actually want to do some manipulation, able to do it, but writing it before await next. Okay, so context response on starting. We have this type of special event here that helps us to register to our response process, and the system will take into account this registration and it will apply your changes before sending data to a user, before sending our response. Okay, so let's do it. I'm just going to do the same operation here. Let me just completely remove this one. We'll talk about this also. And let's just return task completed task. Okay, and I'm just going to run my application and see if I will be able to get my header information. Great, let's just send. Let's continue. And we have, let's see what we have here. Invalid non-ANSI control character. Okay, my header, my value. I guess we have the simple issue here like this, and that's all. Let's run it again. And let's send. Here we are. And let's go to our headers. Here we are. This is our my header and my value. Okay, that's great. So you may be asked what we are able to do after await next. Of course, as I mentioned, you should do some logic related to response if only you are not going to change response. For example, you maybe add some logging mechanism or some logic which is related to your response but not going to directly change your response. Okay, if you want to change your response, one of the best practices to do it using on starting or after await next, you are able to do the context response has started checking. Cool. That's how we are interacting with our response. Now, let's see if we are able to create our middleware using different techniques. Of course, in this case, if you are not calling your await, it means you don't want your request to flow to the next middleware, and it is going to create a terminal middleware. Okay, it is called technically terminal middleware or short circuit middleware. If you directly want to create short circuit middleware, you are able to do it using app.run. So this is similar this one, but we have some overriding here. So you see we have 3 overriding, and this third one is working with request delegate. We'll talk about this request delegate when we create another way, or when we use another way of creating our middleware. But for now, let's just focus to our implementation. I'm going to provide my context. So you see, I don't have the next here. It means I'm just going to terminate my operation here. I need just to do some operation here and stop my flow. Okay, so if my context request, I think without if we can do it. So context response that write asynchronously, and here we are, and this is going to be a waitable operation. Let's run it. In my case, I have a simple request here. I'm just checking header, then I am terminating my operation. Let's send, and it should flow to the run, and run should terminate our operation. And let's see. Let's go to our body. So you see we are getting this information here. Cool. Using app.run or using just use without a wait, you can terminate your operation if you want to just create a simple stuff over your web API or over your any type of ASP.NET Core application. But as you can see, that's not all about our middlewares. Here we have really cool naming stuff, but this seems like a little bit ugly here, because we have use Swagger UI, we have use HTTPS, redirection, use authorization, but something seems not fitting to the context. So how we can create a middlewares like this? This is really simple. So we need to create our own folder called middlewares. So you can call this folder not just middlewares. You can use any naming stuff you want, but let's call it middlewares. And I'm going to add a simple class here. And my class is going to be change header, or let's go at text to header. Okay, header. Cool. And here we need to specify request delegate. Let's just inject our request delegate. This request delegate is our next item. Okay, and let's inject this request delegate. Let's use just next equal to our request delegate, and we have public async task on invoke, and we have HTTP context here. Content, not content, but context. So, as you might see, this is a little bit similar to our use. Why? Because our use also works with request delegate and HTTP context. But in this case, if you want to create a little bit elegant middlewares, you need to specify a specific class that gets our request delegate and invokes our context. Okay, so not on invoke, but just invoke. And now I am able to do the same logic here. What I'm going to do, let me just maybe copy this one and paste it here. I think the on starting is not a good example. Maybe we can use this one. Let's paste it here. And we are calling our next, just simple. Or you can just do next dot beginning walk. This is same as the next. And the only thing here is the next request delegate accepts our context. So let's provide our context here. And let's do a bit formatting. Cool. Now everything is okay. And we need to add some sort of extension method because all this stuff here, the elegant naming stuff like use HTTPS redirection, use authorization is going to be extension. So you see this is extension. This one is also extension. So this app is our web application. But when you go to the implementation, you see we have our application builder and extension over our application builder. So you can just simply copy this stuff from here and go to the our method public, let's create our class public static class extensions. Let me just copy and paste it here. Use header modification, let's say. And we'll just simply call app.use middleware. And this middleware will call our add text to header. Well, that's simply all. And we need to, of course, return this information. Let's go to our program CS. I am going to completely remove this one. Remove this run also. Let us flow in our pipeline. App.use. Let's get an exact name. Use header modification. Sounds not bad. Use header modification. And let's add our extension public static and use. Cool. I just want to check if everything is working or not. Let's run our application. Let's go to the Postman, send our request. So it's coming here. Let's continue. Let's go to the headers. We have secret information. Everything is working. I am removing my secret information, so we are not getting the response. So that's how we are actually building this sort of elegant middleware elements, middleware components here. Okay, so just simply so you see we have the contract-based architecture here. Because we are not inheriting from any class, you need just inject your request delegate from your constructor, and our use middleware checks if your class injects a request delegate and it has invoke mechanism with HTTP context, then it is able to run our class and call invoke method. Let's see. Let's add some breakpoint, run our application. Let's continue. I'm just going to send request again, and here we are. So you see the request flows, everything is working, and let's run our application again with secret header. And that's all. That's all how we are building our middleware using different mechanisms like use, map. Also, of course, there is multiple ways of creating middlewares, but mostly you will use, run, and this sort of mechanism. But if you don't want to, let's say, learn this way of creating middleware, we have really simple template from the Visual Studio. So you see, when you right click, add, and when you select class, and in your C#, we are able to find our, let's select this .NET Core, and let's find our middleware class, and let's add it. So you see, in our middleware class, we have the request delegate, the same stuff I did with invoke, and we have the same injection mechanism. You can just use it without typing everything manually.